Hello everyone, my name is Agustín and I work in the support team at Percona, and we are going to talk about how to efficiently deploy PostgreSQL instances. And I would like to mention a quick disclaimer here that this is not a talk referring to production environments. So we mainly do this for our testing environments, or it could also be done for either development or QA environments you have. So the main focus is not going to be production systems. So having said that, let's move on to the agenda. There are going to be three main topics that we are going to discuss here, and these are why, what, and how. Or why do we need to care about how to be efficiently deploying PostgreSQL environments? What tools can we use, and how can we use them? So going to the first topic on why, there are again three topics I would like to mention here, and these are the first one, and not in any particular order. It's not that like time is more important than the others, but we do have some time constraints when we are dealing with customer tickets, and these are due to the SLAs that we have with them, or the service level agreements that we have with them. Imagine that there is a customer that has an urgent problem. We have a certain amount of time to reply to that ticket by like contractually, right? So time is a very important factor for us when it comes to deal with customer tickets. So we need to be able to deploy environments that let us test in a timely manner when we need to. It's not like for every ticket we will create an environment, a testing environment, but if needed, we certainly need to do it fast. Then the second point is, of course, money. If we can do more work in any time slice, then that is going to be more effective for everyone involved. Let's go back to point number one, and let's think that there is a customer that has an urgent ticket open with us, and that is most of the times reflecting negatively on the revenue that they can have at a certain time. So money is, of course, a factor when we are discussing dealing with customer issues. Okay, so the faster we can do it, the more we can save our customers money, and that is like a win-win situation. Okay. Sorry. The third point here is our own sanity, and the first two were customer facing, if you will. This is more of from our side, right? If you avoid doing repetitive work, you will work in a more efficient way yourself. At least I know that within our team, we try to automate things that can be automated. So in this case, we avoid doing dull work and we work in a better way. So having said this, what tools do we have at our disposal to do this? We are going to talk about three tools for this. The first one is AnyDB-ver, which is a tool developed by our own Nikolay Ihalanian, and it actually supports not only Postgres, but MySQL and derivatives, and MongoDB and the derivatives like Percona server for MongoDB. So when you are using AnyDB-ver, you have the additional benefit of having out-of-the-box support for MySQL, MongoDB, and Postgres. So if in your company you are using any of these three tools, it's a very good potential tool for you to learn if you need to efficiently deploy environments like this. Then we have PostgreSQL Sandbox, which was an initiative I took when I was starting with Postgres. I noted that we had some manual ways of deploying binaries, and these I just did like compress them into some steps that were basically copy pasted every time I needed a sandbox. And then I thought, okay, I'm using this so much that I would much rather dedicate some time to developing a tool that can do this for me than continue doing this, right? So PostgreSQL Sandbox comes after this realization, let's say. And then, of course, everyone knows this tool by now, and it's Docker. And we can deploy some non-complex environments, let's say, very easily without much of a performance hit. So let's go a bit into in more depth into these tools. Let's discuss some pros and cons of each. And I would say that this is one of the most important parts of the talk. At least I would much rather have you understand which tool is better for you than how to use it, because how to use it you can just learn by checking documentation and online documents. So but I think that the most important thing here is for you to realize which of the tools is better for you. That is for me the best the best first step. Okay, so let's start by NADB ver. And the main positive aspects from it are that it can support complex environments. And by complex, I mean environments like replication, a primary and a secondary, or two secondaries, or n secondaries, and HA environments with that use Patroni, HA proxy, or PGPool. Okay, so if you need to set up an environment that involves replication and other tools, NADB is something for you to be aware of or check. We are going to discuss the other two tools briefly, but I'd say for now I have to say that they won't support complex environments, at least not out of the box. Okay, the second point is that it can use containers. It can also use virtual machines. So overhead is really minimal, I think. Performance hit is not an issue, I would say. And then lastly, that it can even run Kubernetes operators and Percona monitoring and management, which in short is PMM. If you're not familiar with this, PMM is a tool we designed for monitoring, again, MySQL, Mongo, and Postgres environments. And if you're not familiar with it, I would suggest that you check some of the talks on it, because it's really cool. It has a lot of benefits and a lot of functionality. So it can, apart from running complex environments, it can even operate Kubernetes operators and monitoring. On the downside, we have that you would be needing another layer of software, either be complexity in terms of you having to diagnose when it's not working, or you having to know how it works, or even if the performance hit is minimal, there is a performance hit involved, right? So that is the downside of the other things we discussed before. And then the second one is that it takes a bit of time to start the nodes. Let's say that you can have in a somewhat complex environment that would involve, and we are going to check this later, Patroni and 3 nodes, 1 primary and 2 replicas. You can have around 8 minutes of downtime, not downtime, but 8 minutes until you can start using the environment, which is kind of a lot. There are ways of bypassing this. You can create a cache and you can decrease these times by a lot, but it it won't work the first time, of course. So the last point to mention is that it is a more complex tool than the other two, so it will have a more steep learning curve. That will mean that initially you will have to be familiarized with more commands and more ways of using the tools than you would with the other tools. But I would say that in the end it pays off. But still, it's something to know, right? So if you're in a hurry, or if you don't really need complexity that this tool will bring, you may be better off with other tools. Okay, so moving on to PostgreSQL Sandbox. As I mentioned before, it was just created with the kind of motto of being simple, right? Both to develop and maintain and to use. So the functionality it has is really basic, just create, use, and destroy, right? Doesn't have support for these quote unquote complex environments, and it doesn't natively support, for instance, setting up replication. You can do it. You can just start two sandboxes and then connect them via configuring replication. But those are additional steps you have to do. Um, the good thing is that it's simple, so you will have less time from when you start reading documentation until you can really use it. Just if you learn just 3 commands, you will be able to use it. So I think that's a very good point on in its favor. The second point is that it does run binaries directly, so there is no performance hit, at least from other layers of software. So if you're concerned about your test environment's performance, this is a good option for you. And then it's very fast. It really takes seconds to start. I don't have any timed commands like I did with NADB ver, but I tell you that it's really seconds. There's not much overhead in that sense. On the downside, we have that it doesn't support complex environments, as we mentioned. It has no protection from in case that you hit bugs or errors in misconfigured variables. For instance, you take a lot of the memory for cache. Your server may run out of memory, and the OM killer is maybe triggered. So we don't have the security layer protecting us like we do in the containers or the VMs. So we need to be careful, and maybe this may be a high price to pay. So again, take it into consideration if you are using, for instance, a shared server to deploy this, where you may affect your colleagues or other people if you make mistakes in either configurations or, I don't know, versions used or whatever. And then lastly, that if you're familiar with MySQL or MongoDB, these databases have tarball distributions, which are just it's just another way of saying that they provide packed binaries. Okay, so PostgreSQL doesn't have this, and this means that we will need to compile our own. It's not difficult, but it's another step, and yeah, I would say that it is a negative point for it. And lastly, for Docker, we have that it's really everyone, as I said before, everyone nowadays knows it, and it's everywhere. So that's a point in favor. It's also very, very fast. There is very little performance hit from using containers, and it's just very simple and straightforward to use. So that's another point in its favor. And then another cool thing is that Docker Hub provides ready-to-go images. In our case, we are going to see what happens if you don't have the image locally and you need to get it from somewhere. It's just really easy. Docker does it naturally, and you don't need to any other steps that involve you using any official, let's say, officially backed image. You can even upload your own images if you make changes to there any currently available image. And on the downside, we have that again, as any DBver, it's another layer of software, okay, with everything that entails. In this case, I'm more focused in the negative aspect of it, but it also has its benefits, as we mentioned before. Okay, so this is not just only negative, but it has a negative component to it. And then the host and container interaction may not always be possible or simple, right? For instance, let's say that you want to attach GDB to your running PostgreSQL container. If you didn't run it with a privileged kind of deployment, you won't be able to do it, for instance, right? So if you would like to, I don't know, get the perf and have nice flame graphs from your PostgreSQL container, it may not be possible for you to do it. Another thing to have into consideration, okay? And then there is no support for complex environments. Again, as we discussed with PostgreSQL Sandbox, which any DBver does and does really, really good, in my opinion. Okay, so this was the brief introduction to the positive and negative sides for each tool. And lastly, we are going to discuss how to use them. Again, very briefly, and the takeover you should have is mainly the basic commands to do to have the basic interactions with the tool. There are many other ways in which we can use them, and I would say that you should be, first of all, reading the documentation. Okay, so the first point we're going to discuss of each tool is getting help, and then creating, using, and destroying the environments, and finally, how to check which instances we have running and have access to the logs. Okay, so we are going to start with AnyDBver. We're going to see these 3 topics for this tool, and then we're going to move with the other tools. The first thing I would like to mention, and this applies to all of the tools, is don't forget about online documentation. Many times it has much more information than the help outputs that you can get from the command line interface. So if you ask me, I would first go to the online documentation. Okay, and only then use the --help or the help command when we need to refresh some concepts or some commands that we need. Okay, so we have the documentation in this link, and then we can also have the help subcommand give us information. Moreover, with AnyDBver, we can have AnyDBver, a subcommand, and then help to get help from that subcommand in particular. Okay, in this case, how to use deploy in the tool with Postgres. Okay, how to create it? Okay, we can use deploy to create our environments, and we just need, in its most basic flavor, we just need to use PG and then the version we want. We can, optionally, we can use dry run to see which arguments and environment variables it's going to use. Okay, so let's see a more complex environment here. And as I mentioned before, this took 8 minutes, and we have 1 primary node and 2 secondaries, okay, which are connected to this. When we don't use anything here, by default, it's node 0. So we are telling that the primary here is node 0. Okay, and for the tool to install Patroni and connect this environment with it. Okay, we will have a lot of output here, and the important thing is to check if there are any failure. It uses Ansible, right? So if there are any failure scenarios here that had happened. Okay. In this case, everything went okay, and again, it took 8 minutes to start a 3-node replication setup with Percona. How to use it? Very simple. NDBver SSH. It will by default log us to the node 0, and then we can use just PSQL and have access to the PostgreSQL database. We can even use PerconiCTL to list which nodes are in the environment here, and we can see that there is 1 leader and 2 replicas. Okay, and finally, to clean up, and this is very fast as opposed to creating it just needs to remove the containers that were created, right? So to 4 seconds, really nothing, no issues with the destroy command. Okay, if we need to list them, and the beaver list, it will get us our all the nodes we have deployed. It will give us some extra information like the IP addresses, if they have any snapshots. Okay, again, really simple. And then finally, how to check the logs as you would with any PostgreSQL deployment, right? So we just connect to the node, either the container or the VM, whatever we are using, and we can check the initdb logs or the PostgreSQL logs. Okay, in this case, there are no errors, but this was just an example to show you how to get to these logs. Okay, that was all for NDBver, and let's quickly move on to PostgreSQL Sandbox. So again, this we can use the dash help to get a hint on what commands and arguments we can use. In case of PostgreSQL Sandbox, the online documentation is not as polished. This is something I need to work on, but the dash help in this case is a very good reference if we need to check the commands and options used. Okay, so not much to see here. Let's go to the create, use and cleanup step. If we decide to use, there are several ways of using it. I think the most straightforward way is just setting the environment with some predefined binary and sandbox directory. Okay, so after that, after doing this command, the tool will create an environment file that will use every time we use PG Sandbox from that directory, right? So setenv will create an environment file in this directory. And then if we change directory to this directory, we will be able to use PG Sandbox without repeating the arguments, which I think is really convenient, right? So this is just one way to use it. If you feel more comfortable always using the -b and -s and -p, if you are using ports, for instance, you can also do that, okay? And then this is what I was mentioning that takes really seconds. Create is, let's say, an alias for initialize and start. Okay, so it will start, we'll create the data directory, it will initialize it, and then it will start the server. And this just takes really seconds. We have the binary running then, and we can use PG Sandbox use to log into it. If you're familiar with DB deployer or MySQL Sandbox, this is quite similar in that sense. We can just use some predefined binary running in a predefined sandbox directory. Okay, and this will give us access to the PSQL client as would with NDBver, as we saw before. And then you can also have PG Sandbox, the use command, and all these arguments that you add after the subcommand will be sent straight to the PSQL client. If you add them before, they will go to the use command itself, to the PG sandbox command, let's say. If you use it after, it will go to the PSQL command. Okay, so we can do stuff like this, which is very convenient. How can we use, let's say, binaries in the binary repository we have, right? So this is a functionality that will let us do transparently call binaries that are in the directory we defined initially, right? So if you remember, this is the -b we used. Okay, so let's say we want to create a new DB, that a new database that is named test. We can easily do this by executing pg sandbox --add dsn. This just means that it will run the create DB command with the appended arguments to connect to this PG sandbox in particular. And then the last argument is sent to create DB, which is the name of the new database we can create. We can even use this with PG dump all, for instance, if we want to take a backup of our sandbox. And we would again use it in this way. PG sandbox at dsn, the run subcommand, and the binary name that we want to run. And then we just redirect this to an output file. Okay, and to clean up the environment, again, really simple, PG sandbox destroy, and in this case, it will prompt us to double check if we really want to remove the contents of the directory that is pointing to, that is pointed by to the environment variable, okay? And then to list, there is currently no support for it. We can do it if the project gets traction and people want it. It's not impossible, but for now I didn't have much more time to dedicate to the tool, unfortunately. And I left it as is because we do have a workaround. And with this command, we can check which sandboxes we have running under our OS username, let's say, right? So in this case, I had 3 of them running in here, okay? And I can just simply change the directory to these and use PG sandbox stop or PG sandbox destroy or whatever. Finally, how to check the logs. The sandbox directory will have the data directory in it, and in the data directory we will have the server log. Okay, so again, no particular issues in here, but just to demonstrate how to reach the log. Finally, Docker, and I'm really going to go fast here because we are reaching the end mark, and I'm sure most of you already know how to use it. Again, Docker --help, but I would first go, in particular with Docker, I would first go to the online documentation. How to create it, very simple. And this is the example I mentioned before. If you don't have the image you want to use locally, Docker transparently goes and checks in the Docker Hub to see if that image is available. If it is, it will download it for you and it will use it. All very simple and easy, okay? In this case, since we are using a shared server, we like to name the containers after ourselves, so each of us knows which container is from whom, okay? And then, yeah, you can use environment variables and the image, which in this case is from upstream Docker. So this is the official Postgres Docker image, and then the label with the version, okay? How to use it? Very simple. There are mainly 2 ways. You can use docker exec and log in to a bash and then run the PSQL command over there, or you can, instead of running bash here, you can use this PSQL command and it will take you straight to the PSQL interface. We can clean up in the following order. First, the container has to be stopped. If not, Docker won't allow you to remove it. Okay, so we need to docker stop container name, and then docker rm-v container name. The -v just tells us to remove all volumes that are associated to it. This will save you space. If you don't want to, just to be on the safe side, don't use -v and then review and remove the volumes yourself. Okay. Then finally, how to list and check logs. Docker PS will show us the running containers. Docker PS-A will show us all the containers running and stopped. And then finally, Docker logs container name will show us the outputs from the main process that is running, which in this case is, of course, the Postgres binary. Okay, if not, if you need to log into a container, you can do it as we did initially with docker exec it container name and then bash, and then just use it as a regular bash shell to that container. Okay, and that was it. In case you have any questions, you can let me know over Discord or send me an email at to agustin.gallego@percona.com. Okay, thank you very much for your time and have a nice day.